Hey, and welcome to The Explainer. Let's be honest, for a lot of us, the word algebra can be a little intimidating. But I promise you, by the end of this, you're going to see it for what it really is. Not some scary monster, but actually a super powerful, even elegant tool for solving puzzles.
Okay, so let's just dive right in. And instead of starting with some, dry formula, we're going to kick things off with a mystery, a classic word problem that might look a little bit tangled up at first.
All right, here it is. This is our puzzle for today. Just take a second to let that sink in. Our mission, which we are definitely going to accept, is to solve this together. And by the time we're done, the way we get the answer is going to feel totally simple. So how do we even begin to attack this thing with any kind of confidence? It feels like a jumble of words and numbers, right? Well, the secret isn't about being some kind of math genius. Nope. It's about learning a new language. A really simple one, actually, for talking about things we just don't know yet.
And that right there, that's the whole key. You see, algebra isn't just a bunch of random rules to memorize. It's a language. And today we're going to get a handle on its basic grammar so we can systematically solve for pretty much any unknown.
This is really the heart of it. We use letters, like the famous X, as a kind of placeholder for a number that's a mystery. The moment we can represent our unknown like this, the puzzle suddenly starts to look a whole lot clearer.
And in this new language, there are really only two main words you got to know. First, you have constants. Those are just the numbers you can see, the fixed values, like the 47 or the 3 from our problem. And then you have variables. Those are the letters, like our X, that stand in for the number we're hunting for. That's pretty much it.
Okay, so if algebra is a language, then an equation is like a full sentence. And every single algebraic sentence has one golden rule, one law you can never ever break. It has to stay perfectly balanced.
This is the most important concept for solving, well, just about anything in algebra. Just picture one of those old-timey balancing scales. If you put a little weight on one side, what happens? It tips. To keep it level, you have to add the exact same weight to the other side. The same thing goes for taking weight off or multiplying it or dividing it. Whatever you do to one side, you must do to the other. You got to keep it balanced.
So, this all boils down to a super simple three-step game for solving most equations. First, you simplify. You just clean up both sides, make them look tidy. Next, you start moving things around by adding or subtracting terms. The goal is to get all your numbers on one side and your unknown on the other. And finally, you isolate that variable by multiplying or dividing to get it all by itself.
Let's put it to the test with a really simple one. 5x equals 15. Now, steps 1 and 2 are already done, so we can jump right to step 3. To get x all by itself, we need to undo that times 5. And what's the opposite of multiplying? Dividing. So to keep our scale balanced, we divide both sides by 5, and we get our answer. Boom. 3. The unknown has been found. See? It's a system. And it just works.
Okay, so we've got the basic rules down. But before we go back and solve our main puzzle, I want to show you a little sneak peek, a glimpse of where this language can really take you. These are called algebraic identities. Think of them as power-ups or cheat codes that reveal these really cool patterns in math. So that equation we just solved, 5x equals 15, it was only true for that one specific number. But an identity is an equation that is true for any numbers you decide to plug in. It's not just a specific solution, it's a universal truth. A shortcut that always works.
These are pretty much the big three you'll see everywhere. They give you a kind of blueprint for handling common expressions without doing all the messy work. Let's just focus on that first one, the square of a sum, and see why it's not just some random rule you have to memorize.
So why is that formula actually true? Is it just some rule someone made up? No way. You can actually see it. Imagine a big square, and the length of each side is a plus b. Well, the total area is, of course, a plus b squared. But look what happens when you slice it up. You can see it's made of a smaller square that has an area of a squared, another tiny one with an area of b squared, and then two identical rectangles, each with an area of a times b. Add all those pieces up, and you get the formula. It's not magic, it's just geometry.
And knowing that pattern, it lets you pull off some seriously cool mental math tricks. Like say you need to calculate 104 squared.
You just think of it as 100 plus 4 squared. And now you use the identity. A squared is 10,000. B squared is 16. 2 times A times B is 800. Just add those up in your head. 10,816. You just did complex math in seconds because you knew the pattern.
All right, that was a little detour into algebra's hidden power. Now let's bring it all back home. It's time to use our new tools, our language of unknowns and our rules of balance, to finally crack that puzzle we started with.
So we're back to this guy, but this time we have a plan. This shouldn't look so intimidating anymore, right? We know what to do.
And that plan is this clear 5-step strategy. It's our roadmap. You read the problem carefully, you pick a variable for your unknown, then you translate the words into an equation. You solve that equation using our balance rule, and finally, you just double-check your work. Simple.
Okay, this is the magic step, the translation. We'll let X be the number of girls, since that's what we don't know. Now let's break down the sentence. 4 times the number of girls, well, that's just 4x. 3 more than that becomes 4x plus 3. And the problem says this is 47, which is just a fancy way of saying equals 47. And look at that. That messy sentence is now a clean, beautiful equation. Now all we have to do is solve it. We subtract 3 from both sides, which gives us 4x equals 44. Then we just divide both sides by 4.
And there it is. X equals 11. We got it. There are 11 girls in the class. We did it. So we solved a word problem. Big deal, right? Well, yeah, it actually is a huge deal. Because this process, this logical way of thinking, defining what you don't know, building a model, and then solving it, that's a skill that's used absolutely everywhere.
I mean, this kind of thinking is literally the backbone of physics, letting us predict how planets move. It's completely essential for computer science, forming the logic inside the apps you use on your phone every single day. And it's totally crucial in finance for modeling everything from how an investment grows to the interest on a loan.
You see, in the end, algebra isn't really just about X and Y and some dusty old textbook. It's a powerful framework, a system for taking any problem that has an unknown, giving that unknown a name, and then systematically, confidently finding a solution. It really teaches you how to think. So I guess the real question is, what puzzle, what unknown X in your own life are you going to solve for next?